Hi, I'm Z. You probably know this because that's what your computer has told you. But how does it know that? This is a partially satirical talk. It's intended to be mostly factually accurate, however, some of the details are stressed for comedic effect. This talk may contain opinions. None of these opinions are the opinions of my employer. I hope you enjoy this catharsis. You may want to make sure you all are muted. This is probably going to make you laugh, and I get speech jammed if I start hearing you laughing. I'm also planning on publishing this publicly, so please avoid mentioning privileged information at the Q&A session at the end. So before we talk about complicated things, let's start with the basics. This is how Unix systems authenticate. They have some files in /etc that are effectively plaintext databases for usernames, IDs, groups, and password hashes. And those are what are used for this legacy authentication flow. You start with a login program running as root, such as /bin/login, and then it gets your username and password. Then it checks etc password to see if your user account exists. If it does, it grabs the user ID and uses that to look up more information from etc groups to build up a little dossier. Then it takes your password and does some crazy math to compare it to the hash password in etc shadow. If it matches, or someone forces it to match through malicious means, then the login program forks a child process, impersonates your user account based on that dossier, creates a login shell, and finally sends off to do whatever it is you want to do to the poor computer. That's it. That's how the classic System 5 authentication stack works. Technically, I'm stretching it a little bit, as etc shadow is a fairly recent add-on, mostly because etc password is world readable by design for some arcane reason that I can't easily find in Google. But it's basically that. There's a few steps I'm leaving out for brevity, but they're mostly boring things that only nerds care about. This Unix authentication model is really that simple. You can explain the high-level details on a single slide that was hastily written at 8 a.m. in about 5 minutes. However, because of this simplicity, it leaves attackers with a small list of targets to try to trick the computer into mucking with. But it does work, mostly. Some of the huge downsides is that it only works on one machine at a time. This made sense for the time. Unix was created when the model was to have a big old mainframe for a company and then have everyone connect to it. But in the meantime, we've gone around carrying supercomputers in our watches and always having a calculator in our pockets. Miss Van Ham, you should have been more forward-thinking than to insinuate otherwise in second-grade math class. Because of this, and the fact that said supercomputer watches also run a full-fledged Unix kernel, we can't really rely on a model created for 1970s mainframe technology to get the job done in this day and age of hyperconverged cloud-federated femtoservices. That last sentence probably set off the beard-twitching alarms, so yes, there are some workarounds here. You could just put the files on a network file system. That would make them immutable to whoever tries to mess with them on an individual machine. However, the peak of network file system security on Linux is don't get your network hacked, lol, so they probably won't add a kernel mode. They won't add the ability for a kernel mode file system driver to make TLS validated sessions, so you can use this thing called cryptography to secure access to file system and data on the wire. They're busy arguing about how people should send plain text email and the like. I mean, you could also put these files on a CD, set the immutable flag on or the file system or something, but all that will do is make changing passwords more expensive, annoying, and filled with dread and sadness. What's that? I think I hear something coming. It's SSHD. Turns out we do need something more complicated because we have networks in the cloud and complicated multi-factor auth requirements for acronym compliance. We can't really do that with Unix authentication because it was designed before such things were even a glimmer in the eye of security professionals. Surely, there has to be a better option out there somewhere. Et voila, c'est le PAM! Turns out someone else a long time ago had the same problems and somehow got legal to sign off on making it open source. PAM is a modular system for making authentication and authorization work. For reference here, authentication and authorization are being split up into two concepts here, like they are in a lot of the information security industry. We're going to take a page out of the White Hat's Guide to Security here and call these concepts authentication, who you are and how we know who you are, and authorization, aka, can you really take all the money out of the bank account? It's a solid 90s solution to a 70s problem, and good God, it shows. PAM was made in the 90s by this little startup nobody here has heard of called Sun Microsystems. They had a problem where they had a bunch of machines to apply complicated authentication rules to, all thanks to those pesky enterprise contracts, and no way to really do it. Money won this valiant fight between engineering and sales, so we ended up with PAM. So, you're probably wondering something along the lines of, how does this thing work? Carefully, that's how. This is a screenshot of a text file, a common thing to do these days, of the main PAM configuration file in a distribution called Alpine Linux. I'm using Alpine Linux here because its PAM file is one screen of text compared to the whatever Ubuntu is. PAM has a few kinds of modules, as you can see on the left column. Authentication. This is not just checking your password, but also making sure that your account exists and you're able to log into it, and setting up things like your preferred login shell. The account, things that assign user account based on the circumstances of their authentication or validate that somehow. This is also where an LDAP server would get thrown into the mix if you really hate yourself. Password, this is the thing that actually checks your password. Sometimes Google Authenticator will be thrown into here, etc. And then finally, the last type of modules are sessions, which they handle other system errata, like making sure the message of the day is shown when you log in, or letting login know about the session so it can make you cgroup for you. All of these modules are implemented as dynamically linked libraries in C, as we know, the height of modern programming security. And PAM works by loading out all of these files out of /lib/security, throwing them directly into RAM, and then executing arbitrary C functions out of them to see what they return. Yeah, really. I'm kind of surprised that the modules are written in C and not Java, given that it was from Sun. If you typo this configuration file and don't have a root session open with your box, it is even worse than typoing the etc sudoers file. Typoing etc sudoers will make it impossible to use sudo. Your system can limp along in the meantime, or you can directly log in as root or something to mend the situation. But typoing the PAM file will cause glibc to hold your wife and children hostage until you forcibly reboot the system and hack back into it so you can regain control. How is this relevant to us? Well, I have a little bit of a side project going on. I've been trying to write a PAM module that would use Tailscale as its authentication method. When you're on a Tailscale network, you're already behind a two-factor auth trust barrier. If we know who you are, and you are authorized to connect to the server by its ACLs, why should we subject you to the surreal horror of local authentication logic in order to let you SSH into the server? We know who you are. You're allowed to connect to it, so why stop you? Right here is some Rust code, and it's basically the heart of the PAM module that I've been writing. It sets up syslog for its log sync. This is really your only good option in PAM land, given that you're executing in some arbitrary user space process. It grabs the status of the network from Tailscale and finally makes sure that your IP address is in the tailnet. This probably should be more complicated in the future. I've had ideas for sending a TSMP message to the source machine to prompt you with a "Are you sure you want to do that?" style message, but they are just ideas right now. But yes, the rest is a bunch of random boilerplate code to deal with PAM's nonsense, making sure that the C AVI functions are exposed correctly, and other helpers to grab things from Tailscale with Unix sockets. This is written in Rust because I firmly believe that writing security-critical components that we ship with the operating system in C is a massive disservice to our users. Go doesn't really have a good story to do interoperability with core system components like this. The Go runtime is massive, and at the time of writing this post, the entire PAM module I've written is smaller than the Go runtime, even with a statically compiled copy of libcurl. Plus, I also get the chance to point out this little question mark at the end of the third line of this code blurb. That is an if error not equals nil, return nil, comma, error statement. It's handled at compile time, and it'll even return the OK side of the result into a value if there is one. I understand why Go can't have nice things like this, but it would take at least 7 lines of code out of my keyboard firmware if we had this nice thing in Go, not to mention countless editor macros for other people. If you want to peek around the C module part of the PAM project, the QR code will take you there. I'm fairly sure that I can get away with this. I made my appropriate sacrifices to the demo gods this morning. So I have the VM that I've been testing things on. Try SSHing into it. If you're watching the recording of this talk or you are not in the core tailnet, at command won't work. However, you should see something like this. I have a screenshot of me tailing the syslog output file and grepping for the word authing, which prints where users are authenticating as people. It would be really cool to flesh this out as a full product. I feel this could really make people's lives a lot easier. The hard part is going to be making sure that this absolutely has security experts pour over this to make sure that this is actually safe. I'm fairly sure that it's safe as it is, but right now this is an Uber hammer that lets you log in as root if you get SSH access to a system, which potentially makes it easy to escalate privileges around from a malicious npm module. I would love to have this send a TSMP message to have a GUI prompt validate that you want to do this as a kind of second factor for authentication, but even in this limited state, I feel this has a lot of value. Something that came up while I was working on this, and something you might wonder, is how do you debug PAM? It's something. I'm currently trying to get this thing to work on Ubuntu, and all of the paths that I have taken are fraught with despair. I have not managed to lock myself out of my Ubuntu VM yet, but it is really fighting me. You know you're in for a ride when you're relying on obscure PDFs of ring binder manuals that have been poorly maintained tell you to do things that literally do not exist anymore. I've had to use a combination of GDB and strace to get anywhere with this. PAM is a surreal horror because the most terrifying part is that it works and that there's not any other good options. There are some other options in other ecosystems. OpenBSD has BSD auth, Plan 9 has Factotum, but we don't live in that world, sadly. We're Plan 9.1. These things do exist, and there are a lot of valuable things that you can learn from them, but we can't really use them because PAM won. Especially if we want to do this on people's computers where PAM almost certainly has one. And, well, that's the end of the talk. I want to give special thanks to the Council of Elders that I summoned the help of in order to get this far. Without their help and at least 800 Bing points worth of searching, I would never have been able to understand this at all. If you have any questions, you can ask them now. Just remember, you're probably still on mute.
I wouldn't say I have a question, but I did SSH in and found out that it worked and my name showed up in the log file. So I'm excited about that. I also see several coworkers have logged in the last few minutes.
Yeah.
Yeah. Avery, didn't back in your previous company life, didn't you build like an authentication system to replace PAM that was based on like a daemon and RPCs and things?
Yes, I did. It was about as horrible as you would expect. I learned a bunch of things. One of them is that you should do as little as possible in the main process because it gets linked into the binary of whatever is trying to authenticate right now, which might be doing any number of things, including threads. And so if your library has any kind of dependencies or opens any files or allocates memory, or God forbid has its own threads, you're really, really in trouble. So the way I designed it was like a really simple library that pinged into a daemon instead. It worked pretty well. But yes, everything Z said about PAM is true. It is really that bad, and you have to be completely on the defensive every time you touch it.
When I was doing research into ways that people have done PAM in Rust before, apparently the process of grabbing things from PAM environment variables was declared as unsafe, as in sticking your hand in a blender, or terms along those lines, because you basically just YOLO C pointers into Rust memory and pray that everything's right, which is somewhat standard practice in C land, but in Rust that is like a massive yikes.
Yeah, I mean, pretty much the entire PAM API is, I mean, it's extremely C oriented, right? So you're dealing with C strings that have unknown life cycles and all this other stuff. There's nothing Rust can do to really save you from those. You kind of want to get in and out as fast as you can.
That's what I try to do, yeah.
So what's the production status of this PAM module? Will we
Um,
recommend it to customers?
I mean, it it passes some security analysis tools that I've thrown at it, but I would really love to have someone much smarter than me rip it into it and validate it to make sure that it actually does what it says it does and nothing more. I would also love to have like some sort of way to only allow admins to go in as root or other things. But even then, as it is, I'm pretty sure that it has a lot of value and could make people's lives a lot easier. But I wouldn't want to advertise it as a panacea because even though that it is very easy to SSH in over Tailscale, this does nothing to solve the problem for when Tailscale is broken and you need to fix it. I figure that's probably going to end up being out of scope of this module. However, it's something that I am very much keeping in mind and why I don't want to push this out everywhere yet. Not to mention the fact that I can't get it working on Ubuntu, and I'm not sure why at all.
Well, we have to figure that out for sure. I think there's a big difference, of course, between using it internally, where we have this problem where, as the people who make Tailscale, we can't rely on Tailscale to debug our own problems. I think for customers, they should hopefully be able to rely on the fact that Tailscale is working. Or it's our job to make sure that they can rely on that.
Yeah, just SRE hat on and all,
Yeah.
Anyways.
The whole put all, don't put all your eggs in one basket or put them all in one basket and then watch that basket really carefully.